Functions of uniformly accelerated linear motion. I am Olaliri Rabiu. So today I'll be taking us through the equations of uniformly accelerated linear motion. And the target exams are WAEC, NECO, JAMB, GCE, and POSIT-TME exams. So we have the main uh, word in the topic, acceleration. So what is acceleration? Acceleration is the rate of change of velocity with time. That is, whenever there's a change in the velocity of a body, then we say there is acceleration. And velocity simply means how fast or how slow the body is. So a body that's moving slowly, by the time the body begins to move very fast, we say there is an acceleration. The unit of acceleration is meter per second squared. Then mathematically we say acceleration is change in velocity over time. So if there's a change in velocity, which means there will be an initial velocity and there will be a final velocity. So v here is representing the final velocity, u is representing the initial velocity over time. So we say acceleration is v minus u over t. So as we have said earlier, a body can only accelerate when its velocity or speed changes. A body can only accelerate whenever there is a change in the speed or velocity. So a body has zero acceleration when the velocity is constant in both magnitude and direction. So when the velocity of a body is constant, there is no acceleration. A body that's moving along a straight line, a body that is moving uniformly, a body in uniform motion along a straight line that is moving with uniform speed or velocity has zero acceleration. That's because the velocity does not change. But it's possible that the speed of a body is uniform and there is still acceleration, but that will only take place in a circular motion. So a body moving with uniform speed in a circular motion has an acceleration because there is a change in the direction of the velocity. So we look at our equations now. What are the equations of uniformly accelerated linear motion? The equations are s equals to u plus v over 2t, v equals to u plus at, v squared equals to u squared plus 2as, s equals to ut plus half at squared. So from those four equations, we have 5 letters. So those 5 letters, what do they represent? V there represent the final velocity in meter per seconds. U represent the initial velocity in meter per seconds. A is the uniform acceleration itself, which is a meter per second squared. S is distance traveled in meters. Then T is time taken in seconds. So the equations are applicable to a single acceleration. So let's look at some example now. So before we take some examples here, we are going to look at some things which are very important when using those equations we have discussed earlier. The following should be noted when solving problems on this type. 1. The initial velocity u, we use u as the initial velocity. We take it as 0 whenever a body starts from rest. So when you see in the question that the body starts from rest, that means the initial velocity of the body is 0. So you take u to be 0. 2. The final velocity v is 0 for a body that stops or comes to a complete halt. So when a body comes to a complete halt, the final velocity is 0. 3. Acceleration is negative for a body that slows down or a car that applies its brakes to bring it to a halt. So when you have a car that's moving very fast, and let's say the driver sees an obstruction in the way, the driver has to apply the brake. So the brake the driver is applying is this, that means it makes the car to decelerate. That means the speed of the car decreases, so the car decelerates. So in that case, we say the acceleration is negative. So take note of these 3 points. To solve calculation questions on this, we first write out the parameters. So let's see that with this example we want to solve now. So we have our question here. The question says a motorcycle starting from rest. A motorcycle starting from rest is uniformly accelerated such that its velocity in 10 seconds is 72 kilometer per hour. What is its acceleration? So we have our options there: 108 meter per second squared, option B 86 meter per second squared, option C 4 meter per second squared, option D 2 meter per second squared. So firstly, we write out our parameters. So what are the parameters? A motorcycle starting from rest means that the initial velocity is 0, so u will be 0 meter per second. Then it's uniformly accelerated such that its velocity in 10 seconds. So the 10 seconds there is a time. So we are given the time to be 10 seconds, t to be 10 seconds. 72 kilometer per hour. That is our final velocity, 70 kilometer per hour. But when solving question of this type, we have to be consistent with the unit. So if you look at the unit we are given, for time is seconds, but for the final velocity is kilometer per hour. So we have to convert this kilometer per hour to meter per second in order to be consistent with the unit. So how do we do this? So to convert 72 kilometer per hour to meter per second, we know that a kilometer is 1000 meters. So 72 kilometer will be 72 times 1000. Then an hour is 3600 seconds. So 72 kilometer per hour to meter per second will be 72 times 1000, then divided by 3600. So that will give us 20 meter per second. So we have our A unknown, the acceleration is unknown. So from the parameters we are given, we have U, we have T, we have V, and we have A. We are looking for A. So we go to the equations. So I've written the equations down here. The equations here, A is missing, so this equation will not be useful because we don't have letter A. But if you look at this, we have VUAT, V equals to U plus AT. Yes, it has all we need. So we are taking that equation. So we take equation V equals to U plus AT. Then we make our substitution. Final speed is 20 meter per second. The initial speed U is 0. So 20 equals to 0 plus A times T is 10. So when we substitute, we have 20 equals to 0 plus 10A. So we have 20 equals to 10A. Then dividing both sides by 10, A will be 20 over 10, and that will give us 2 meter per second square. So that means the correct option is D. So the answer is 2 meter per second square. So I believe you understand that. So we have some questions here that I want you to try as assignment. So thank you. We have come to the end of the class. Thank you. Bye.